Good morning, friends. Let us continue our discussion in problem number 6. So, as per the question, the problem is given as the resistance value R is given as 20 ohms. The voltage is given as 110 volt, 110 volt, and the frequency of the AC main is given as 50 hertz. They are asking to find out the time taken for the current to change from its maximum value to the RMS value. So by the formula we have I equal to I0 cos omega t. So since the frequency is given, I take it as 2 pi nu into t. That is the omega value. And the IRMS value is given as IRMS is equal to I0 by root 2. So when I am comparing both, I take the first equation as 1 and the second equation as 2. So when I am comparing both the expressions, I get the value for t. I am equating it and I am comparing both the expressions. I get the value as, so I am equating them. Therefore, we get it as t equals 1 by 8 nu. So I am just rearranging the expressions. The next part is, therefore, I am substituting the values. T is equal to 1 divided by 8 into nu is 50. So I am expanding it up. So it is T is equal to 2.5 into 10 power minus 3 seconds. So T is equal to 2.5 milliseconds. So we can see that the option D is the correct option. That is it. The next problem is, the frequency has been given. The frequency is 50 hertz. What is the minimum time taken to reach the peak value is being asked. So I am going to expand the previous problem here because I've done directly T is equal to, I am just given the value. So in this problem I will be explaining how I got it. So I is equal to I0 cos omega t. So I0 by root 2, IRMS value is I0 by root 2 equal to I into cos omega t. So I0 and I0, both the equations are same, I cancel it off. I0 by root I0 and I0 will get cancelled. Therefore we get it as 1 by root 2 equals cos 2 pi nu into t. So here 1 by root 2, that is, we are going to find an equivalent for that particular value. So cos pi by 4 is nothing but 1 by root 2. So when I am substituting it up, cos pi by 4 equals cos of 2 pi nu into t. So both the sides I just remove it. So we'll get it as, the pi values are cancelled. So you'll be getting it as 1 by 4, that is on the left hand side, is equal to 2 into nu is 50, that is the frequency, into t. Now I am rearranging it up. So when I rearrange the expression, I got it as t equals, t will be equal to 1 by, or 1, just I bring the to denominator, 1 by 8 is equal to 50 t. Therefore t is equal to 1 by 8 into 50. So when I am expanding it up, when I am dividing it up, 1 by 8 into 50, so it is 2.5 into 10 power minus 3 seconds. So the previous problem I skipped that part because I am going to do it in the next problem. So that is the explanation for the sixth one's expansion. So when you check it over, the answer is B option is the answer. So this is how we are solving it. Now we are going to discuss the eighth problem. They are asking the phase difference between the current and voltage. A circuit diagram is being given I am drawing the circuit diagram. So an alternating source is given. To an alternating source, an inductor coil and a resistor is being connected. So the value of the alternating source is given as V is equal to 2 cos theta into, that is 2 cos theta 100t plus 5, and the value of the inductor coil is given as 20 millihenry and the resistor is given as 2 ohms. So this is the circuit diagram they are given. They are asking us to find out what is the phase difference between them. So between the current and the voltage, they are asking the phase difference. So the voltage is given as 2 cos theta 100t plus 5. So omega is, from this the value for omega is taken as 100 and L is given as 20 millihenry as per the problem, and the value for resistance is given as 2 ohms. So these are the data given in that particular diagram. Now we are asked to find out the phase shift between them. So what is the phase shift pi, they are asking. So this is the first, you have to interpret what is being given. Now when you are telling about the phi angle, phi is given as tan inverse of XL minus XC by R. So here only the inductor coil is given. So I am removing the capacitor part. Therefore tan inverse of XL by R will be the formula. So when I am substituting it, it becomes tan inverse of, instead of XL, I take it as omega L by R. So because XL is the inductive reactance. So tan inverse of omega is nothing but 100 into the frequency value is, so omega complete value I am taking it as 100 into the inductor value is given as 20 into 10 power minus 3 and the resistance value is given as 2. So it is 100 into 20 into 10 power minus 3 by 2. So I am cancelling it off. When I am cancelling it off, you will get it as tan inverse of 1. I will get it. All the numbers will be getting cancelled. So phi is equal to tan inverse of 1. Therefore phi is equal to 45 degrees. So when I am checking over, the option is A option comes over it. So as per the question, the answer is, the option is A. So this is how we are solving this sort of problems. The next problem will be discussing about the reactance. What will be the reactance they are asking? So the alternating voltage and the current has been given. So E is given as 100 sine 100 pi t. 100 sine 100 pi t is being given. So 100 pi I take it as omega. So E0 sine omega t. So E0 will be 100. So this one complete part I take it as omega. So 100 I am taking it as E0. Similarly, the value for I is given as 5 sine 100 pi t. So I take the first equation of voltage as 1 and the second one as for current as 2. Now from the problem we are going to discuss what is being given. So E0 is nothing but 100. That is the part I take it as E0. E0 sin omega t, that is the format. And for I0 I take it as 5 because it is I0 sin omega t. So I0 as 5. So now I have taken the E0 and I0 value. So what is ERMS value? ERMS given as E0 by root 2. So it is E0 as 100 by root 2 volt. Similarly, IRMS is taken as I0 by root 2, which is nothing but 5 by root 2 amperes. So current is ampere. So I got the two expressions. So for ERMS I got one and IRMS I got one. Now we have to calculate what is the reactance of the circuit they are asking. So the reactance R is nothing but voltage is equal to IR, therefore R is equal to ERMS by IRMS. Therefore R is equal to, ERMS is nothing but 100 by root 2 divided by 5 by root 2. So I am taking the reciprocal. It is root 2 by 5 into root 2 by 5 because I am taking the reciprocal when it is coming to the denominator. So root 2 and root 2 getting cancelled. 100 by 5 is nothing but 20. So the resistance becomes 20 ohms. So when I check over the option, the answer is C option comes under this particular category. So the answer is C. When I'm checking over the option, it is the C option. So I take the answer as C. So this is how we are also going to solve these sort of problems. Now we'll be continuing the 10th problem. So here, as per the problem, the voltage value Vrms is given as 220 volt and the frequency is given as 50 hertz. So and the inductor value is given as 1 Henry. Therefore, what is the inductive reactance? So XL is taken as omega L, so which is nothing but 2 pi nu into L. So I'm just expanding the value for omega. So it becomes 2 pi, 2 into pi into frequency is 50 into the value for L is 1. So get it as 100 into pi, so it is 314 ohms. 100 into pi value is 3.14, so get it as XL equal to 314 ohms. Now they are asking the peak value of the current. Therefore, IRMS is equal to the peak value of the current they are asking. So it is VRMS by XL. So IRMS first we are calculating it. So it is VRMS is 220 divided by the XL value is given as 314. So when I am solving the expression, XL value is, I am going to solve the expression 220 by 314. I am skipping that part. I am skipping the calculation. So IRMS becomes, it is almost 0.7 amperes. The value is 0.7 amperes. So IRMS I got it. They are asking the peak value. Therefore, peak current I0 is equal to I0 by, that is IRMS into root 2. The peak value is given as I0 is equal to IRMS into root 2. So it is 0.7 into root 2 is 1.414. I got it as I0 is equal to multiplied by 1.414. So I get it as almost 1 ampere. So when I check out the answer, it is the C subdivision. So the correct answer for this problem is C. So we have solved almost 10 problems. Thank you.